All right, so this is a series parallel combination, and it says resistors 1 and 5 are connected in series, and 2, 3, and 4 are connected in parallel. That means that if I draw it, I am going to have, it's going to look like this. So what we have is it says 1 and 5, so this one and this one are connected in series, and 2, 3, and 4 are connected in parallel. Now, if they said 1 and 2 were connected in series, and then 3, 4, and 5 were in parallel, then this one would be over here because I would go through 1 and 2 first before I would hit the section where it breaks up. But according to the wording here, this is what it should look like. Now, when you're doing a series parallel combination, what you're going to do is you're going to take that, and then you're going to simplify that picture there into this picture. All right, so what I'll be doing is 1 will still be 1, and 5 will still be 5, but 2, 3, and 4 are going to be simplified, and they're going to be combined to get one equivalent resistance right here. That's why I use subscripts, because we actually are going to have 2 equivalent resistances in here. We're going to have the one that we just combined the parallel, and then we're going to have an equivalent resistance of the entire circuit. So as far as the numbers, we're going to have, let's see, it's a 60-volt battery. So since there are 5 resistors out there, I'm going to use as my subscripts 1, 2, 3, 4, 5. All right, because between getting from the higher terminal to the lower terminal, there are 5 in its way. It doesn't mean that every charge is going to go through every one of them, but there's 5 there. Then I'm going to call this one over here R1, and that is given in the problem as 2 ohms. R2 is given as 3 ohms. R3 is given as 4 ohms. And R4 is given as 6 ohms, and R5 is given as 5 ohms. All right, so that's the more detailed picture. So on the picture below, we are going to still have R1 is still going to be 2 ohms. And R5 is still going to be 5 ohms. And voltage on the whole thing is still going to be 60 volts. But now we need to figure out what R2, 3, 4 is. So we need to get that. So we're going to do that by taking, let's see how far down I can come here. We're going to go 1 over R234. So when you're combining resistors in parallel, we have to take the reciprocals. We add up the sum of the reciprocals, and that will be the reciprocal of the answer. So this is going to be 1 over 3 ohms plus 1 over 4 ohms plus 1 over 6 ohms. So if that's what we have, what's our least common denominator? 12. So we're going to have 12 ohms. And to go from 3 to 12, top and bottom by what? 4 plus. To go from 4 to 12, top and bottom by what? 3. And to go 6 to 12, top and bottom by what? 2. All right, so now that's the reciprocal of R234. So R234 is going to equal 12 ohms divided by 9. And if we solve that, that's, what, 1.33? So 1.33 ohms. So I can put that on this picture, 1.33 ohms. Well, now that I know that, now I can get the equivalent resistance of the whole circuit, and I want that because I need to figure the current that's going to leave our battery. So R1, 2, 3, 4, 5 is going to be add 7 to 1.33, so we're going to get 8.33. And once I know that, the next thing I would want to solve on this first picture, on this less detailed picture, once I know the equivalent resistance of the whole thing and I know that, I can now solve for the current that leaves the battery. So the current that leaves the battery will actually go through each one of these. Now I know it gets broken up here, but for now, I can figure out what the total is of current that passes through the middle resistor parallel section. So we're going to get I 1, 2, 3, 4, 5 is going to be V 1, 2, 3, 4, 5 divided by R 1, 2, 3, 4, 5. So that's going to be 60 volts divided by 8.33 ohms. And what does that equal? What's 60 divided by 8.33? 7.20. So now that I know that, without solving anything, without doing any other calculation, I now know, I'm going through this quick without asking you because I just want to make sure I can fit this in under 15 minutes on this thing. So once I know that current, then I know that 7.20 amps is there, 7.20 amps is there, and 7.20 amps is there. So that means that I know that I1 equals I234 equals I5 equals 7.20 amps. Right. Now, once I know those three, then I can solve for the voltage drop across each one of these. And that'll be my first, well, that'll be my first check because they should add up to 60 volts. So I can get V1, I can get V234, and I can get V5. So those would be the next three things I'm going to solve. I'm going to solve them at the same time. So V1, V234, and V5. So V1 will be I1 times R1. This is going to be I234 times R234. And this is going to be I5 times R5. And that's going to be, set up the parentheses. Now the thing is, I'm solving them all at the same time. The one common fact is that the I's are the same for all these. So for all three of these, it's 7.20 amps. And now we're going to put in the resistors. So R1 is 2 ohms. R234 is 1.33 ohms. And R5 is 5 ohms. So for the first one, voltage drop looks like it's going to be 14.4 volts. And for the third one, it looks like 35, 36. It looks like 36 volts. And what's the middle one? 7.20 times 1.33. That's going to be what? That doesn't sound right. 7.2 times 1.33. 9.57. So we'll say 9.6 volts. So they're all to the nearest tenth of a volt. And if I add those all up, I'm going to get, let's see, 0, 7, 16, 20, 5, 6. I get 60 volts. And so there's my first check. All the voltages do add up to 60. Now, when I test you, I'm not going to ask you to solve, well, I mean, what I think you should do is solve everything, but then I will have questions like, I will say, what's the voltage drop across the 2 ohm resistor? Or what's the current through the 5 ohm resistor? So once you have all this stuff on the board, you can then answer each of those questions because they'll be there somewhere. Now we're done with this picture right here. So the only thing left to do is figure out how much of the current goes through each of these 3 resistors. So that's the only thing left. So we'll do that. So the next thing is we're going to solve for I1. I'm sorry. We're going to solve for I2, which is going to be V2 over R2. We're going to solve for I3, which is going to be V3 over R3. And we're going to solve for I4, which is V4 over R4. Now, one thing that I forgot to put in here is that once I know what V2, 3, 4 is, then I know what V2 is, I know what V3 is, and I know what V4 is. Because if you look up here, whether I go, so I'm going to lose so much voltage there, but when I go here, whatever voltage I lose, I'm going to lose it in getting from here to there. Whether I go that way, or whether I go straight through, or whether I go through the bottom. Whichever way I go, I'm going to lose the same amount of voltage, and we already calculated that. That's 9.6 volts. So 9.6 volts no matter which path we take through the parallel section. So we're going to get 9.6 volts over R2, 9.6 volts over R3, 9.6 volts over R4. So what was our, let's see, 2, 3, and 4 were 3, 4, and 6. So 3 ohms, 4 ohms, and 6 ohms. So calculating those, this looks like it's going to be, what, 3.2 amps? And this one looks like it's going to be 2.4 amps. And this one looks like it's going to be 1.6 amps. And if I add those 3 numbers up, let's see, 3.2 plus 2.4 is 5.6, 7.2. So they do add up to 7.2 amps. So everything checks. And then the only other thing that I could ask you to solve at this point is, I could ask you to solve for a power. You now know all the individual voltages and all the individual currents through each of the resistors in there, so you can solve for power.